In this lesson, we are going to learn counting principles and probability. We are going to use the subjects and the acknowledgement about the addition principle, multiplication principle, permutation and combination in this subject. We are going to use the help of this subject. Okay, the number is selected at random from the 3-digit numbers formed using the digits 1, 2, 3, 4, 5, 6, 7 without repetition. If you remember, we were solving this kind of questions. We were solving this kind of questions without repetition questions with multiplication principle. And if you remember, we were writing box for them. And we were saying like this. This is the first digit, this is the second digit, and this is the third digit. Okay. And how many different way we can select, not how many different, find the probability that the selected number is an even number. So this is the sample space it's going to be. And how many different ways you can select without repeating from this set 3-digit numbers. We are going to find that one, and it's going to be 7 times 6 times 5. Why it's decreasing? If you remember, 7 and then you used one number, then 6 different number you can use, and then you can use 5 different number. That's why the answer is going to be 7 times 6 times 5. What about the event? In event part, we are looking for the even numbers. So, for the even numbers, the number, 3-digit number should end with the number 2, 4, or 6. That's why here I can write only 3 different numbers. So, 3 possible cases there are. And when without repetition, I should start from the end. Then here, when you use one number, 2, 4, you had 6 different number, then 5 different number is going to be. So the answer is 6 times 5 times 3 is going to be. When we check the probability of the event, number of elements in the sample space, which is 6 times 5 times 3 over number of elements in the sample space, it's going to be 7 times 6 times 5, that is. So 6 and 5, as you see here, we can simplify. The answer is 3 over 7 is going to be. Okay. A machine generates all 3-letter sequence of the letters kahve. So we have the set kahve, and in our set we have K, A, H, then V, then E. This is like numbers. Okay. With repetition allowed. So it means that you can use one letter, let's say A, 3 times you can use in your 3-letter word. Each sequence is written on a card and the cards put in a box. So we are going to put in a box, and Ömer draws a card. What is the probability? He draws beginning the letter H. Firstly, let me remind you about how many different ways we can write the 3-letter words. And here it's going to be 5 for the first place, 5 for the second place, 5 for the second place, because repetition allowed. So it's equal to 5 times 5 times 5 is going to be. Okay. How many of them starts with H? Starts with H means there is only one case for this one, that's H. And the others, they are not important. You can use 5 different. Also, you can use H. Also, it's not problem because it's not written here each only once. So you can use many times one letter. Then here it's going to be 1 times 5 times 5. And if this is the sample space, this is the wanted event it's going to be. And the probability of the event is equal to number of elements in the sample event over number of elements in the sample space it's going to be, which is equal to 1 times 5 times 5. I'm consciously not multiplying them because I'm going to simplify now. 5 we simplify, the answer is going to be equal to 1 over 5. Okay. 6 people, including Murat and Saim, are seated around the circular table. Find the probability that Murat and Saim sit next to each other. If you remember the circular permutation, for the circular permutation, the formula was n minus 1 factorial for n people, we can sit around and the circular table n minus 1 factorial different way. But here we have another problem in the question. Murat and Saim, they want to sit together. So Murat and Saim, they're going to sit together and they're going to make one group. And there are other 4 persons, person 1, person 2, person 3, person 4, and Murat and Saim, they are going to be together. That's why that's going to be the 5th person. Like as when they are grouped, they are going to behave like one person. That's why we are going to accept as there are 5 persons around the circular table. If there are 5 persons around the circular table, 5 minus 1 factorial they can sit, and these 2 people around the circular table, circular table, and this 2 factorial arrangement between the group members, it's going to be okay. Then this is the wanted event from us. This is the number of elements in the sample event. But we need to find also, for the probability, we need to find the sample space. What is the sample space? Without rule. 6 people, how many different ways can sit around the circular table? If we have 6 persons, 1, 2, 3, 4, 5, and 6, we are going to say people 1, people 2, 3, 4, 5, and 6. So this is the NS it's going to be, and it's equal to 6 factorial different way. So probability of the event is going to be equal to 5 factorial, which is, 4 factorial times 2 factorial over 6 factorial. It's going to be in the exam, calculation parts belongs to you. Okay. A box contains 4 yellow marbles and 6 red marbles. 2 marbles are drawn random. What is the probability that both marbles are yellow? Here, when we select 2 marbles, we are going to use this method here. We are going to select 2 marbles from 4. This is the number of elements in the sample space. And we are going to select, totally there are 10 marbles, 2 marbles. And this is the sample space. In the sample space, we are not giving importance to the colors of the marbles. So from 10, we are selecting 2 of them. But for the event, we are selecting, it says that what is the probability both marbles are yellow. So from 4, we are selecting 2 of them. Then the answer is going to be here, 4 factorial, permutation of the event is equal to 4 with 2 over 10 with 2 is going to be, which is equal to 4 factorial times 4 minus 2 factorial times 2 factorial over 10 factorial over 10 minus 2 factorial times 2 factorial. As I said, the simplifying operation belongs to you. We are going to continue. We are going to continue in the exam if I ask this question. Okay, now again selecting exercise. This is there are 18 light bulbs and 5 of these bulbs are defective. So if the 5 of them defective, 13 of them normal, it's going to be 13 normal we have. And we are going to choose 3 light bulbs, and what is the probability that 2 chosen light bulbs are defective? So from 5 to, for the A1, from 5, 2 of them I'm going to choose, and from 13 I'm going to choose only 1 of them, because from normals only 1 they were looking for, and this is going to be the NE. But here, when we choose 3 light bulbs at random, means totally there are 18 light bulbs, so we are choosing from 18 3 of them. That's why, and this is going to be the NS, and the probability of the event is going to be an E over NS, which is equal to 5 with 2 times 13 with 1 over 18 with 3 is going to be. What about the at least one, B part? At least one chosen light bulb, at least one chosen light bulbs is defective. So 1 defective, 2 defective, and 3 defective case we should think about. 3 defective. So here it's going to be times. When you choose 1 defective, totally you are selecting 3 light bulb. That's why from the normal you are choosing 2 of them. And when you are choosing 3 light bulb in this order, you cannot choose again, let's say when you choose one defective, you cannot choose 2 defective again. That's why these actions they cannot happen together, and we should add them with addition principle. Then 13 with 1 it's going to be plus, and 13 with 1, 13 with 1, and 5 with 3 plus times, because all they are defective, 13 with 0, but 13 with 0 is equal to 1, that's why it's not written here. Then the probability of this event is going to be equal to, I'm going to write all these are 5 with 1 times 13 with 2 plus 5 with 2 times 13 with 1, and the last one is 5 with 3 I have to this part, yes, 5 with 3 all over, it's going to be 18 with 3. Okay, now this is the experiment about the tossing the coin 8 times, and in this experiment, in the previous lesson, I explained when you toss the coin 4 times, maybe we can write the set, but when you toss the coin 8 times, it is not difficult, it's not easy to write the set. So in the sample space, when you toss the coin, there are 2 to the power of 8 possible cases, because when we are starting to count the H and tail, how many different way you can write, here 2 different way, here 2 different way, here 2 different, 2 different, 2 different. If we continue like this, 2, here 2, here 2, and here 2, totally there are 8 now here, and the 2 possible cases when they happen together, 2 to the power of 8 possible cases we have for in this sample space. So 2 to the power of 8 different results. When we toss the coin 8 times, we will get. What is the wanted event? The event that they are looking for is there are 5 heads and 3 tails. So 5 heads they are looking for, and 3 tails they are looking for. 5 tails and 3 tails, when it is written like this, it becomes like 8-letter word, and we know that 8 factorial over 5 factorial times 3 factorial different way, we can order this 8-letter words. So we will get 5 heads and 3 tails, 8 factorial over 5 factorial times 3 factorial different way. This is for H's, and this is for T's, is going to be 3 factorial different way, T's will be. Okay, then the answer of the probability of this event is going to be equal to 8 factorial over 5 factorial times 3 factorial over 2 to the power of 8 is going to be. This is the answer, but simplifying part belongs to you. Again, I'm repeating that one. Okay, a student taking a test which has 15 true false questions. If the student has guessed every answer, what is the probability that he or she will answer exactly 11 questions correctly? And if I say the true false question, there are 15 questions. The first, if you remember from the tossing the coin experiment, in tossing coin experiment we have totally 2 faces, and here there are two answers for the question. It will be true or false. So these are similar experiments. And true or false, two possible case for the first question, two possible case for the second question, two possible case for the third. If we continue like this, here there are going to be 2 to the power of, here there's 10 questions now. Totally now I try to show 15 questions, and the answer is it's going to be 2 to the power of, answer is going to be 2 to the power of 15 different way we can answer the true false question test. Okay, this is the sample space. This is the number of elements in the sample space, and they are looking for 15 true answer. They are looking for 11 true answers. Yes, 11. I couldn't find that word. 11 true answer. So if I write in the, like in the previous question, 11 true, like true, and true here, that 11 true, and the others, of course, the 4 of them, it's going to be false. How many different way we can get 11 true and 4 false, if you ask? Like this is 15 letter word, so this is going to be 15 factorial over 11 factorial times 4 factorial is going to be, so the permutation of this thing is going to be 15 factorial over 11 factorial times 4 factorial over, here I should correct the place of the permutation. I think here permutation of the event is equal to 2 to the power of 15 is going to be, and simplifying part of course belongs to you. This is the number of elements in the event.